හරි අපි අද ලෙසන් එකට සෙට් වෙමු නේද? අද ලෙසන් එකට සෙට් වෙමු. Okay, see this one all. Write down today new topic. Write down today new topic, circular motion. Circular motion. Circular motion. Circular motion. හරි. බලන්න පාඩ circular motion එක ගොඩක්ම simple lesson එකක්. A level paper එකේ applied එකේ question number 12 එකේ part B එකට set වෙනවාමයි. question number 12 part B එකට set වෙනවාමයි මේ circular motion part එක. සාමාන්‍ය මේ question number 12 කියන්නේ ඔයාලට time manage කරගන්න තියෙන හොඳම question එක. හරිද? සාමාන්‍ය හරියට practice කරගත්තොත් විනාඩි 10ක් වගේ යනකොට full ප්‍රශ්නෙම ඉවරයක් කරගන්න පුළුවන්. නිකන් හරිය පොඩි question එකක් තමයි මේකේ තියෙන්නේ. මේ පොඩිම වෙලාවකින් හදන්න පුළුවන් question එකක් විදියට. circular motion part එක. Okay? Now here we discuss about circular motions. And we have two different things. One is circular motion, the other one is angular motion. Circular motion and angular motion. Consider a particle. Consider a particle which trace a circular path. We call circular motion. Therefore, usually a particle trace this circular path. Then it's circular motion. Now consider an object. Consider an object. Then it has made by several particles, no? Then if we rotate about here this point, here this particle moves along a circle. This particle moves along a circle. This particle moves along a circle. Likewise, there are different circular motions with different radius but same center. Same center, different radius. Therefore, this type of motion we call angular motion. Angular motion. Then it has connected several particles with one center. It is angular motion. Then here circular motion. So we mainly discuss about circular motion part. Circular motion part. So we have different type motions. We have different type motions. One is linear motion that moves along a line. Linear motion. Another one is projectile motion. So when we project a particle with some inclination, then the corresponding path we call a projectile. Okay, it is parabolic shape. Then further we have circular motions. Particles move along a circle, circular motion. That can be vertical circular motion or that can be horizontal circular motion. Further we have harmonic motions. Harmonic motion, repeated motion. So usually we say simple harmonic motion. Here simple harmonic motion. So here this part circular motion. Circular motion, simple thing. Then for linear motion, we have physical quantities to analyze this motion. One is distance. The other one is displacement, velocity, speed, acceleration. Okay, these quantities we used to analyze linear motion. So we usually take displacement, velocity, and acceleration to analyze linear motion. Then for circular motions and angular motions, we use new physical quantities. One is called angular displacement, the other one angular velocity, and the other one angular accelerations. Angular accelerations. So there are different types of accelerations behind this circular motion. Okay, our physics වලදී කරලා තියෙන theory part එකම තමයි තියෙන්නේ. Okay, then when a particle moves along this circular path, here t equals 0 position, here t equals t position, then this displacement we call angular displacement. Angular displacement. So that is measured by radians. Angular displacement is measured by radians, theta. So displacement divided by time we call velocity. Here for uniform velocities, it is easy to get displacement divided by time. But for instantly changing thing, we call velocity equal ds divided by dt. ds divided by dt. Using differentiation, we use instant velocity. Here that represents instant velocity, rate of change, ds divided by dt. Okay. Then here also we have angular displacement theta corresponding time t. Then we call angular velocity theta divided by t. Here general definition. Angular displacement divided by time. That is angular velocity. So further, this omega we can denote by d theta divided by t. Changes for instantly changes thing, d theta divided by dt we call angular velocity. Then further, then d theta divided by dt we denote by theta dot. Theta dot, that is equal rate of change. Rate of change. Then that denote by theta dot. Then omega usually denote by d theta divided by dt as well as theta dot. Similar thing. Therefore, when we differentiate it again, then d square theta divided by dt square we call theta double dot. Theta double dot. This is angular acceleration. So here, when we differentiate this one further, we get acceleration. So when we differentiate this one further, we get angular acceleration. Here theta double dot mean angular acceleration, that is denoted by d square theta divided by dt square, that is equal angular acceleration. So when a particle moves along a circle, there are three different accelerations. So one acceleration we call angular acceleration. Then similarly, it has tangential acceleration, we call AT, tangential acceleration. And further we have radial acceleration, AR. Then always AR will appear, but tangential acceleration not always appear, angular acceleration not always appear. Okay? But radial acceleration always appear. It is defined radial acceleration v square divided by r, or r omega squared. This is two possible. AR v squared over r or r omega squared. Okay, තමයි කතාව. හරිද? මේ ටික තමයි one by one analyze කරන්න තියෙන්නේ. Okay, just put a note and write down. When a particle moves along a circle, the corresponding motion is said to be a circular motion. Is said to be a circular motion. Circular motion. Especially there are two types of circular motions to be analyzed. First one, horizontal circular motion. Second one, vertical circular motion. First one, horizontal circular motion. Second one, vertical circular motion. Next line. To analyze circular motions, there are few physical quantities can be introduced. There are few physical quantities can be introduced. There are few physical quantities can be introduced. Okay. Sketch with me. Here, sketch this circle. Here, center. Here, t equals 0 position. T equals t position. Here, radius r. Angle theta. මාත් එක්කම කරමු. මේ ගොඩක් පොඩි lesson එකක්. Okay, now you say theta angular displacement. Angular displacement theta. Here this is S. S we call tangential displacement. Tangential displacement. It has connected by S equal r theta. Using trigonometry we can connect it. Better put ST. Tangential displacement. ST. R theta. Then angular displacement given in radians. Tangential displacement given in meters. මාත් එක්කම කරගෙන දන්න ටික. Then here ST equal r theta. Differentiate with respect to time. Then dst divided by dt, dr theta divided by dt. Here we say vt. R take outside, d theta divided by dt. Then vt equal r. We call this is omega. Okay. Then omega angular velocity. Angular velocity. Then further omega represented by d theta divided by dt and theta dot. Theta dot. That is angular velocity. This is tangential velocity. Tangential velocity. Here vt. Physics වල තියෙන theory part එකම තමයි තියෙන්නේ. අලුතින් තියෙන මේ notations ටිකයි questions type ටිකයි විතරයි. අනිත් ඒවා ඔක්කොම එකයි. vt equal r omega. Then further differentiate with respect to time. Then dvt divided by dt, r d square theta divided by dt square. This is equal at, tangential acceleration, equal r. This is equal alpha. Tangential acceleration. Here angular acceleration. Then alpha we denote by d square theta divided by dt square or theta double dot. මේ notations අපි normally use කරනවා. මේවත් use කරනවා. Alpha equal d square theta divided by dt square or theta double dot. Dot represent derivative with respect to time. Then 2 times differentiation, theta double dot. Here angular acceleration, tangential acceleration. Okay, here we know omega. Here we know omega, angular velocity. Here we have different connections for angular velocity. Omega. See this one? We have different formulas. Now, usually, velocity we call distance divided by time. Distance divided by time. For uniform velocity, displacement divided by time. Then angular velocity, angular displacement divided by time. එතකොට uniform angular velocity theta over t. Omega equal theta divided by t for uniform velocities. Or to find average angular velocity, again you can take theta divided by t. හරිද? Average angular velocity ගන්න theta divided by t. Now further, consider full rotation, then corresponding displacement 2 pi. 2 pi. Then full time we call periodic time. Time for rotation. Therefore, omega further we can write 2 pi divided by capital T. Here periodic time. Periodic time. Capital T. 2 pi divided by T. Another equation. And we call 1 over T as frequency. Then 2 pi F frequency. Then F we say 1 over T, it is frequency. Frequency. Rotation per second. Rotation per second. That is frequency. 2 pi F. Then omega equal theta divided by t, omega equal 2 pi divided by t, omega equal 2 pi f. Three different equations. These are used for uniform thing. No? Uniform උනොත් විතරයි මේක පාවිච්චි කරන්නේ. Then fourth one, අපිට frequency mean rotation per second නේ. එතකොට එක second එක rotations count කරනට වඩා ලේසි minute එකකට rotations count කරලා second එකකට මේ convert කරන එක නේ. Minute එකකට කීයක්ද කියලා අරගෙන second එකකට ගන්නවා. Divide by 60. Therefore, omega equal 2 pi r dot p dot m divide by 60. Here rotation per minute. R dot p dot m rotation per minute. Rotation per minute. Omega equal 2 pi r dot p dot m over 60. එහෙනම් ඔය හතරම අපිට set වෙන omega connect කරන equations. Uniform velocities. And further we have omega v divided by r. Then fifth equation, omega equal vt divided by r. අපිට මේ එක එකව සමහර වෙලාවට පාවිච්චි කරනවා. Now for angular velocities we have 5 different equations. 5 different equations. Okay. Write them. Okay. Now further write down. With stomach write down. For any circular motion, for any circular motion, for any circular motion, there will be a radial acceleration. there will be a radial acceleration. For any circular motion, there will be a radial acceleration that is given by v square divided by r, or r omega squared, v square divided by r or r omega squared. Okay, we mean here tangential velocity. Then remember, for any circular motion, there will be radial acceleration. But angular acceleration and tangential acceleration not always appear. But radial acceleration always appear. How the radial acceleration එක හැම වෙලේම තියෙනවා. Star mark write down. For any circular motion, for any circular motion, radial acceleration is always appear. Radial acceleration is always appear. Radial acceleration is always appear. But tangential acceleration and angular acceleration not always appear with circular motion. Not always appear with circular motions. Okay, next line write down. To analyze circular motions, use the following steps. Okay. Subtopic horizontal circular motion. Step number 1. Consider vertical equilibrium of forces. Consider vertical equilibrium of forces. Step number 2. Use F equals ma towards center. Use F equals ma towards center. Use F equals ma towards center. Next subtopic, vertical circular motion. Vertical circular motion. First step, use conservation of energy. Use conservation of energy. Second step, use F equals ma towards center. Use F equals ma towards center. Use F equals ma towards center. හරි. ඔයාලට සර්කියුලර් මෝෂන් වල තියරි පාර්ට් එක ඔච්චරයි තියෙන්නේ. අපිට ක්වෙස්චන්ස් තමයි කරගෙන යන්න තියෙන්නේ.